Video going. So, how this works with grade cutoff and everything else. You've been told that grade cutoff is pretty much like today, which means that any quarter one grades need to be assignments that happened today or prior. So like let's say we were taking a test today. That'd be like the last thing that I could make quarter one. But you've already taken the chapter 6 test and most of us have mastered it. Like most of the people sitting in this room have mastered that test. So the cutoff for turning assignments in, like revisions, I believe is going to be next Friday. So if you got a progressing on that, when you get it back tomorrow, you would then just do the progressing to mastery, get it turned back in prior to next Friday, which gives you a whole week to do those revisions and stuff. So does that make sense with the fact that we cut off assignments, then we have a window for you to get those revisions done. And then we have revision cutoff.
Is 6 mastery going to be part of quarter 1 or 2?
I believe so. I think it'll be on quarter 1.
Okay.
We'll talk about it tomorrow when I can finally give them back. But I need those people to finish those tests. Which actually, I might as well give the option since we're recording. Could you guys who are not finished, would you go work on these right now so we can just try to get them done and you don't have to use AO? But then AO and extensions, you'll need to go back and watch the video or copy notes from a classmate.
But some of us don't have AO today.
I know. So, like, you could do that at home because the video is just up on YouTube. So, if you guys would go work on these, I would greatly appreciate it. And it shouldn't take you very long. What's up, Katie? A question?
I had finished it.
Oh, well, you still had NF on your test.
Oh.
So then you erase it and turn it back in.
Oh.
Yeah, what's your favorite song? What do you guys think?
And if you get to a point, this is a message for everybody, not just those who are like not finished. But if you get to a point with an assessment, whether it's math or any other class, that you just realize like, I don't know this. Like you can just, and you can always just write us messages or whatever. You can just be like, I realize I don't know this. I need more practice. I'm done with the assessment for now. That's the thing about like our assessments not having like firm grades that happen and can't be changed. Your grade is only a temporary thing. So if you turn it in and you say, I totally don't get it, that's okay. That's a temporary thing. So you guys that just got your test back, if you would like to go to the library to keep working on it, actually just write diagonal there in Cullinan's room. Since there's nobody over there, just go camp out over there. I'm not certain. I cannot keep track of all that.
Can we sit at the big table where we have like clipboards?
Sit at the desks in there. You're fine. Yeah. So today we're going to try to do 1, 3, 1, 4, but I know we need to finish 1, 2 because I just got the request. Anish, you got a question? No, because not everyone's done. I will never post test grades until I have well, not never, but I most of the time wait till I have everyone's grades before I post them. Because right now there's not really a button for NF. Like for not finished, that really I just have to put in there as progressing, which some kids really like, it makes them freak out. They're like, no, I'm still working on it. I'm like, I know you're progressing through the test. There's no grade on there as not finished, which I might ask for that to be added in. Julie?
Without your glasses, you kind of look like the guy from How I Met Your Mother.
Thanks. I've heard I also look like Benedict Cumberbatch.
Yeah. You do look like Cumberbatch. Who's that?
Sherlock.
Hmm?
So like I was just saying to the whole class, if you hit a point that you just realize, I don't know this, then you can just write, I don't know this. And then you just turn it in with that. So, how far did we make it through our 1.2? Oh, we just finished the t-shirts, right? We had just finished figuring out which was the cheapest unit price. So we want to do the same thing here. We want to do the same thing here to figure out which is the best buy. And of course the best buy is always going to be the cheapest price. So we want to figure out the price per what here? What will be my one item? My price per, what am I going to turn into a 1? I don't turn my dollars into a 1. Thank you, sir. Yeah, my fluid ounces turns into a 1. So this is going to be price per 1 fluid ounce. So I would love it if you guys would write that. We're unit rating here, so it has to be per 1 of something. So to jog our memory, since we haven't really done this since last week, how would I figure that out? For my top one, I will take a volunteer if someone remembers how to do it. Julian.
39, the amount of money times divided by fluid ounces.
Yeah, we put our money on top. And we say that divided by, because that's what per tells me to do. So I'm really doing 396 divided by 2, which we can make easier if we look at this as $4 divided by 2, and then take away the difference amount divided by 2. So this actually comes out to be, what is it? 198 per ounce. So that would be our unit price there. For my 836 for 4 ounces. Now we can do some mental comparisons, thinking about $8 compared to 4 ounces. Dom, you got this?
Well, I did 8.36 divided by 4.
Yeah, what'd you get?
Well, I mean, I did 4 goes into 8 2 times, then 4 goes into 36 9 times.
Yeah, so you got $2.09, right? You're able to compute that without a calculator. In my third one here, I'm going to put that closer just because I do not have lots of space. $14.24 for 8 fluid ounces. Andrew, do you got that?
I have
For the third one here.
It's $1.78.
$1.78. And my final one on the bottom, I have $28.96. Almost $29 for 16 fluid ounces. Samantha, do you have that?
Yeah, $1.81.
$1.81. So which is your better buy? Yeah.
8 fluid ounces for $14.24.
So now, Jeremiah, was that the biggest quantity that you could buy?
No.
No. So this goes back to what we talked about last week, where stores will try to trick you. They know that you think if I buy the biggest option, I get the best deal. That's not always true. Here, the second to biggest option was the best deal. And guys, this happens a lot with soda and Gatorade and like any of those sorts of things where it comes in various sizes of bottles. Like if you go to the checkout line at the grocery store, and I just saw this the other day, I forget if I was at Kroger or Geagle or where I was, but they had 20-ounce bottles of soda. 3 for $4. So 3 bottles of soda, 20 ounces for $4. That's $1.33 a bottle, right?
Yeah.
Pretty good deal. The 2-liter bottles were 4 for $5, which is $1.20 per 2-liter. I could get a 2-liter for $1.20 or 20 ounces for $1.33.
What?
Yeah. The smaller item is more expensive than the object that's like over 3 times as big as it. Because the convenience of the 20-ounce bottle at the checkout line, you don't really care about the price. You're just grabbing it because you're like, oh yeah, I'm thirsty. I'll drink this right now. Where the 2-liter bottle has to be more of like a bigger thought, like it's on your shopping list or something like that. Glenn?
Just buy store brand. It's a lot cheaper.
Yeah, but that even happens with store brands where you can have multiple sizes of the bottles. Like when you compare cans to 2-liter bottles and you look at the price per ounce, and Kroger does this for you. It's on the price tag thing. It tells you the per ounce price.
I was shopping. We went to the store with my dad. I don't remember where we went, but they were doing like a 3 for $4 deal.
Yeah.
And it was actually more expensive to buy 3 for $4 than if you just bought 4 regular price.
Interesting. Yeah, normally the sales have to be better.
It's
So
like a few cents less.
a lot of times with math, you want to set up, and I don't structure it as rigid as this, But you kind of want to think through, what do I need? What do I know? Let's make a plan. So we call it here in the notes the need-know plan, and we have it like very, very structured. I don't care that you set it up with what do I know, what do I need, and what's my plan. I just want you thinking through these things. So let's say that we know a certain water pump moves 330 gallons of water in 22 minutes. And then we're asked to solve, and if you've looked forward in your homework, you'll see a lot of problems like these. You're asked to solve how much water it can move in 39 minutes. Am I being asked for the unit rate here?
No.
No.
But yeah, you do need
But I need to find the unit rate to solve this. Now that, or I could set up a proportion, and we'll look at proportions here next chapter more. So right now, let's first find the unit rate. In this one, I gave you the plan on this one. So I would like you to underline or highlight. First, we find the unit rate. Then, we're going to use that to multiply by what I'm solving for. So since my unit rate is going to be gallons per 1 minute, then since that's the amount in 1 minute, and I'm asked for 39 minutes, I just take my unit rate
multiply by 39.
and multiply by 39. So to find my unit rate, I'm going to zoom out a little bit here. If this comes back. I'm going to take my 330 gallons of water over the 22 minutes. Sean?
15 gallons per minute.
We get 15, and we can call that like GPM right now if we want, gallons per minute. Just like they use miles per hour, MPH. We can always kind of just shorten it down. So then I take that 15, and because, now, if you would please, write this out now, 15 gallons per 1 minute. And what we're doing is multiplying by the 39 minutes, and that's just really over 1, so that our units of minutes do what with each other? Ooh, not cross multiply. They are cross. They cross cancel. Anything that is the same on top and bottom cancels, so my units will just end up gallons. So you don't have to show this every time, but this is why it works. Why I take my unit rate and multiply by the amount of minutes I've been given, because my minutes was on bottom, so now I put it on top. And what is 15 times 39? Anish? 585. And my label on that will be gallons. 585 gallons. By the way, if you haven't figured this out yet, we are not going to make it as far as I anticipated. We're going to have to push this a little bit. I will change due dates.
I know we're going to finish this side and we're only going to finish.
Yeah, we'll start on 1-3 for sure. And we'll probably get through 1-3 because it's pretty quick. 1-4 is very similar to 1-3. So once you understand 1-3, you can probably do 1-4. But I was hoping in my really lofty goals that we might take your mastery on Friday for this chapter, but I really don't think that's going to happen now.
Were you sick yesterday?
No,
The only reason I'm running as well as I am today is coffee that is, we bought this new creamer and it's really chocolatey and I'm now all like jazzed up, but I went really, really like, you know, like, no. You know how people, like some people do like a lot of things all the time, some people are like do less things, and Mrs. Goldring yells at me a lot for this. I do a lot all of the time. And this past weekend was Otterbine's homecoming, and I just did way too much and got my body run down. So Monday I was feeling like crap, and then Tuesday morning I woke up and my body was mad at me. If you've ever had that happen, if you've like practiced really hard or had a really intense game, and then you wake up the next day and you're like, oh my gosh, I got hit by a truck.
It just happened to me the day after I passed out food.
Yeah, that sucked. I still wanted to go to Cane's. They wouldn't let me. Like, I was going to sleep all day and then go to Cane's, and they wouldn't let me.
Why? Oh, how the hell?
I mean, technically, if you take the day off, you shouldn't, like, go out and do things, but I didn't have a fever, so I wasn't contagious, so it was more like I just felt terrible. So I decided to give you guys a day to catch up on homework and everything, but then they wouldn't let me go to Cane's. So now they will never let me live that down, probably. But between you and me, I do an awful lot around here. So it happens. try this problem on your own. If you know that an astronaut's diet contains 18 milligrams of iron for 2 days, an astronaut's diet is very, very structured, which if you've watched the movie The Martian, comes down to a giant math problem, bless you. He only has food for a certain amount of days, and he has to figure out how to stretch that food for the amount of days until his supposed rescue that could potentially happen. I don't want to ruin the movie.
That was
So,
an awesome movie.
Yeah, if you haven't seen The Martian, I would suggest it. Get parent approval. He swears like twice.
Mr. Cabilo do that?
No, more than
You should watch
Have
the
you read the
film
book?
Dearest Song.
But
the book swears a lot. That is the best.
Did
movie
Mr.
ever.
Cabilo do that in Mars?
I don't know. Mr. Cabilo's not really a
The
botanist.
movie
Oh, he
actually
didn't.
is.
Oh, he didn't completely major in
They
it, but he
did
did
some- well,
study.
Yeah, I mean,
they
you just
did
have to
science
understand
behind
plants.
it. So what about
That
so
it
it could
could-
actually you could actually
Let's
plant
watch a film
potatoes, but
Oh, yeah, I've done that. Where you cut potatoes and plant them. That's how you plant potato
and the
plants.
seeds
That
would
actually-
have
it's also how
happened
you plant
because-
pineapple. You just cut the top off.
Would that have actually
There's no
worked?
way pineapple.
Yes.
So you could actually live on Mars.
Oh my gosh.
Yes. Once you establish an atmosphere, go research Elon Musk.
Oh,
So,
isn't it true
if-
that if we make a greenhouse on the moon and we just start expanding it, we could eventually make a complete atmosphere out of the trees?
So, in the potential danger, because as soon as I finish this, I'm going to leave it to go research. We got to get back to the math. If you're curious about Mars and our plans with Mars, go look up Elon Musk / the company SpaceX. Elon Musk has a plan to colonize Mars.
Yeah, I heard of that.
However, the terrible part of this plan is essentially the assumption the first group of people will not come home / they'll probably die.
Yep.
Like, we are trying to colonize a desolate planet that maybe once, potentially, thousands of years ago had water. Like, hold on. So this is a really big thing. I'd like you all to know more about it before we try to engage in conversation with that. So if you're curious, go look it up. We cannot talk more about that today because we got to keep moving.
That's so cool.
Pluto's not a planet anymore. What is it now?
It's a
Doesn't even matter because it's too far away for us to care about it. It is really, really, really far away. It takes over a year to get to Mars. So yeah.
I'm never.
So you would be put in a hypersleep. It wouldn't matter. Who can solve this problem for me? Dealing with my astronaut diet for 9 days.
Wait, what's hypersleep?
Jeremiah, we haven't really talked much math yet.
Me?
Me or him?
Jeremiah, okay. Tavella. No.
I'm
Gosh.
Bella.
The other, I know Smith and hold on, Han.
Tone.
Hone.
Yeah. Okay, so.
I need to just change your card to just Hone and just Smith. I just need to stop using your guys' first names.
Okay.
Okay. Remind me
So I
that
set
later.
up 18 milligrams. Wait, yeah, is that milligrams?
Yeah.
Over. Oh wait, I actually solved it. I didn't really use your rubric at all.
I don't care. Go ahead. Tell me what you
Over
did.
2 days, and I divided it by 2 because
So you got.
I got 6 milligrams over a day.
I don't think
Oh,
so.
that should be
No. Wait, yeah, so
Yeah,
9.
that's what I
Yeah,
thought.
9.
This looks like
So we get 9 milligrams per day is what we know.
Wait, this is basically division.
And then I multiply it
Okay.
by 9 days.
Yeah, so we need 9 days diet. So we take our 9 days times our 9 milligrams per 1 day. My days will now cancel with each other, and I get
81 milligrams.
what's your plan?
Stretch it out over.
Yeah, that's why I don't necessarily care about this whole box process, because our plan would be unit rate times number of days, but we can really just carry it out. We don't have to.
Hypersleep.
Also, how would that
Yeah,
person
like they
survive?
freeze
Like,
you?
No, that's
they need
cryosleep.
9 times as much iron as they have.
Yeah, that's hypersleep.
How would
No,
they
so
survive?
an astronaut's diet contains 18 milligrams for 2 days worth of food. So let me make sense of this for you in relation to the Martian, if people will please stop interrupting. He looks at the food that is rationed out for a team of, and don't correct me because I've watched the movie once. There's like a team of 4 or 5 people there, right? So they've got enough for their mission. I'm going to make these numbers really easy to work with. They've got 20 days left in their mission. I'm making stuff up now. And there are 4 of them. So they've essentially got 80 days of food, like 80 people days of food left. Because they were going to be there for 20 days, 4 people, 80 days of people food, right? So if he ate a day of food every day, he'd only have 80 days of food. So he then looks at what's the absolute minimum requirements for my diet I can get away with, and starts to take each day of food and divide it and make it multiple days of food to stretch it out. So what this is saying is if he knew I must get 18 milligrams of iron in 2 days, well, really, they would have told him you need 9 milligrams of iron every day. So then he says, well, if I want to last for 9 days, how much iron do I need? I need 81. If I want to last for 100 days, I'd do my 9 times 100. If I want to last for a year, I'd do my 9 times 365. So depending on if it's a leap year or not. Huh?
Wait, would you put that
In
in
space.
0.25? Or
Sorry, I still couldn't hear it.
would you put it as like the 365.25 or like however that is because it's like 365 and a fourth day?
We normally just refer to the year as 365. I know technically it's 365 and a quarter because of the lunar cycle and we catch up every leap year, but yeah, it's all, yeah.
What
Jeremiah.
is hypersleep?
Like where they put you to sleep longer. It's like medically assisted sleep so that you don't wake up.
You wouldn't realize it would only feel like 1 day to you.
Yeah, like can you tell time while you're sleeping?
No, it's
No.
like you instantly wake up.
So that, like, if you ever like fallen asleep and it felt like somebody like, and then you're awake and it's morning. So that's like what hypersleep would be, except you'd fall asleep, it'd be like that, you'd wake up and it'd been months. But they would have to wake you up to eat, or like we talked about in this foundation today, you'd have an intravenous, intra meaning. So they could just put you to sleep with an IV and stuff that would give you your food and nutrients and everything that you need, that you could just not wake up and that'd be
So you
fine.
live with your family for 2 years.
Hibernation.
Probably for the rest of, if you went to Mars, unless they were gonna come, you'd probably never. I mean, you'd video chat. We'd set up space
So you
satellite.
wouldn't
rooms.
ever come back
Do you
home.
think cryosleep is
Not the first group of people going to Mars. That
That's
according.
what the
So
astronauts-
I'm not going to answer any more questions until you guys do your research.
We should get a lunch.
If you're curious, look it up.
We should have lunch together so we can.
Acadia, can you walk me through this problem? Still talking about space. If we have a satellite traveling 2,272 miles, by the way, MI is miles, MIN is minutes, just M, excuse me, and I know I used it somewhere else, is normally reserved for meters. So if you see just M, that's normally talking about meters. If we're talking about minutes, we normally write out the whole MIN. So, Acadia, what we want to solve, how far can that satellite travel in 3 minutes?
So you do 2,272 divided by 8. And that is 280.
So we get 284 miles per minute.
And then you multiply that by 3.
And then we multiply that by 3. So I would take my 284 times 3, 852. And then we could label that miles, but if we want to be more specific, we could say miles in 3 minutes. Now, what if I asked you how far this satellite goes per second? What if I want you to change your unit rate from miles per minute to miles per second? How would I do that, Moss?
So I would first change the minutes to seconds, which would be 60 times 3, which would be 180.
You could if you were going to work down here, but we don't need to work down there. We could do it from right up here. Because your work was actually going to have more work in it than what I need to do. And I don't want to do more work than I need to do. Because you are going to do more than one step, right? I can do this in one calculation. Sean?
284 divided by 60.
Yes.
I convert my minutes up here. We did this like once last week by using a conversion factor. So my conversion factor will need to put minutes, since it starts on bottom, it needs to be on top. I want to turn this into seconds, so I determine my units first, and then I say, oh, okay, 1 minute is 60 seconds. All I need to do is take 284 and divide by 60. And when I do that, what do I get, Sam?
4.7 and 3 repeats. 4.7.
4.7 and only the 3 repeats?
3, 3, 3, 3, 3.
So, guys, that is miles per second.
Dang. Son.
So, right now, 1,000 in that amount of time, it went 4 miles, almost 5 miles.
Is this true?
Well, I don't know if this is verified true information, but stuff in space travels ridiculously fast. But really, and I'm going to look this up actually. We should travel, or we should calculate how fast we're currently traveling.
Super slow.
On the earth.
So think about, we're on the surface of the Earth. The Earth is moving through space, like the ball itself is moving, and it's spinning. So you're like on a ride at the fair that is not only moving like this, but you're moving like this while you move like this. Yeah, it's like the teacups. So you're going really fast. You just don't realize it because you're always going really fast.
So we have super speed?
Well, not that you have it, you're just moving with
so
the
are you
Earth.
saying, so if we eventually did colonize Mars, if we had like a family that had a kid up there, and the kid was like 20 now, and he like came back to Earth, would they feel completely different? That's a movie they're making.
No, so think about that. So no, hold up. First difference would be gravity.
Yeah, they'd be accustomed
But
to Mars
it
gravity.
depends on the atmosphere that they would have set up, whether it would have fake gravity or not. And so you're talking about the difference in speed. That's like when you get on a plane and you get used to the speed. When you get in a train, get used to the speed. Get in a car, get used to the speed. So you wouldn't really feel a big difference with the speed because your body corrects that very quickly. But the atmosphere and the gravity, that would be the biggest feel. Like right now, we know how much we weigh based on Earth's gravity. Weight is not it's a relative thing.
It's how much gravity.
Mass is a constant. Weight is relative to where you are. Real quick.
If we actually ended up going to Mars, wouldn't like a person who went to Mars, like let's say he's 20, he comes back a year later, technically wouldn't he still be a 20 since Earth rotates?
He would not be able to be back here a year later. That would be
It
impossible.
have to be 2 years later.
It'd be multiple years because it takes over. Like,
But wouldn't his
I keep saying this and I actually have to stick to it now. We got to shut down this conversation because we got to get through some of this lesson. We can't, like, literally not move forward today. I enjoy this conversation. I would like to talk more about it, but outside of class. Ratios with fractions. You've already done this,
What?
which is why I know we can move through this quickly. We have already done this. How do I deal with division of fractions? Ooh, you have a hand, right, Andrew? Oh, hey, look, a hand. Andrew.
You can change it to multiplication.
We can actually convert to multiplication. So what they start with here is a fraction over a fraction. And I want you to notate that this is the main fraction bar. So I have a fraction in the numerator and a whole value in the denominator. So if I wrote this out, this would really be 4/5 compared to, or in a ratio with 6. Because my main fraction bar is really the division. Does anyone have questions on how I've rewritten this horizontally? Jeremiah?
There are
Home?
2 bars for some reason.
I know. This is the fraction bar in the numerator, which is this fraction bar.
That doesn't.
Thi-
That makes sense.
This is a horrible way to write it. That's why I'm trying to tell you, we can identify, and here's how. And it didn't, so I deleted the situation here, or there was no situation. But what you want to look for is which part has the fraction. Is it my numerator part, the first part of my ratio, or the denominator part, my second part? So they essentially set this up as 4/5 compared to 6. And then I can turn my 6 into 6 over 1. And we can essentially turn this into 4/5 times 1/6 and get 4/30 or 2/15. Now, here's what they do. Put your hands on it for a second because I know we have questions, but I've not gotten to explain things yet. They look in the numerator. This is a complex fraction, a fraction involving a fraction. So they look in the numerator, they say, we have a fraction in the numerator. How do I get rid of this fraction? I can multiply by 5, and that will destroy the division by 5. But I can't only do it to the top, so we have to do it to the top and bottom. That becomes 4/30ths, which I can then reduce, and I get to my answer. Or my suggestion, set it up horizontally, and then keep, change, flip. So what I have written here is another option. I would highlight, circle, or star that. Another option here. When we have a ratio or rate that involves fractions, we can multiply the numerator and denominator by the, what's it called when we just flip it?
Reciprocal.
The reciprocal. And this is the same as keep, change, flip.
Why are those spaces so big?
What do you mean?
Like the lines are big.
Because when I use these, I have to write really big because I'm always real zoomed in. Yeah.
What's the difference between reciprocal and
Commutative.
no?
Additive inverse.
Yeah.
Additive inverse is the opposite. So if I start with 2, its additive inverse is -2. The reciprocal just flips it. So the reciprocal is 1/2. Additive inverse is the opposite. Reciprocal is just it flipped.
And multiplicative.
Multiplicative inverse is the reciprocal. So all you do is flip it.
So multiplicative inverse and reciprocal are basically the same thing.
Because the goal is a number times its multiplicative, or its its reciprocal equals 1. A number plus its additive inverse equals 0. So it's whether we're trying to equal out to 0 because we're adding, or equal out to 1 because we're multiplying. Let's talk more about that outside of class if you would like. Your neighbor commutes 12 miles to work and you commute 9/10 of a mile to school. Write the ratio of your neighbor's commute to your commute as a fraction in simplest form. I do not suggest that you start as a fraction. I suggest that you start your ratio written out horizontally. So we have your neighbor's commute to your commute. Your neighbor's is 12. Yours is 9/10. So I just write it out as a ratio with my colon. I just write it out as a ratio with our colon. We then can say, well, that colon is really division. And that 12 is really 12 over 1.
Whoa. Oh, it's so easy.
And now it can really just be looked at as a fraction divided by a fraction. This is what I meant by you guys already did this.
Whoa.
And it becomes 120 over 9,
And then
which
repeat,
becomes
repeat.
40 over 3, 43 1/3.
Wait,
What?
I can reduce this by 3 if I divide by 3 on top and divide by 3 on bottom. But then 40 over 3,
40 over 3 is 13.
I think I'm just going to
15
leave
over
it
2.
there. What?
Oh no.
It's not 15 over 2.
I'm
I
gonna
40,
can't turn 9 into
over
2.
3. 40 divided by 3 is 13 repeating.
Yeah, so,
13.3.
but because I want a ratio or a fraction in simplest form, I can either leave it here as 40 over 3, or I could write it as a ratio of 40 compared to 3. So his commute is 40, where your commute is 3. Now, that's a weird comparison, right? So if you wanted to really compare how much like how much is his commute times your commute, you would need to get your commute to become a 1, which is where this would be 13.3 repeating. So his commute is approximately 13 times as much as your commute. Because if your commute is 1, his is 13.3. But if yours is 3, his is 40.
Okay, makes sense.
Write the ratio of your commute to your neighbor's commute. So now that what is this changing? The order, right? Do I need to redo the whole problem? No. Just change the order. So we already got 40 to 3. If I flip the order around, it's just 3 to 40. And then how these ratios are related, when I change the order of the ratio that I'm asking for, all I end up getting are reciprocals. If I change the order of what I'm asking for, because this was 40 over 3. This is really 3 over 40. 40 over 3 compared to 3 over 40, they're just reciprocals. You're confused. They changed it to asking for your commute first and your neighbor's commute second. Originally, your neighbor's commute was first and your commute was second.
Yeah, but if we did the same thing up at the start, 12 over 1 and that kind of stuff, you redo that.
It wouldn't start with, this would be completely turned around.
Yeah, but it would end up being 108 over 10.
No, it wouldn't. So,
I do.
your commute, I'm going to zoom in even further. Your commute, 9/10, right? Your neighbor's commute, 12. I can put 12 over 1. That then can become 9/10 times 1/12, which becomes 9
I totally messed that
to
up.
1/20th,
Yep, I forgot.
which reduces to 3/40th.
I forgot to flip.
Any other questions on that example?
Good job.
Try the got it on your own, comparing running time to weightlifting time. Running to weightlifting.
And if I don't get it, I'm gonna watch the video.
Where's reciprocal? That would have been on that line. Guys, pretty much if it gets written on the board, it should be written in your notes. You don't have a textbook. This is what you refer back to. So when I set up my ratio of running to weightlifting, Ashley, how much time do I spend running? 3/4 of an hour. And guys, make sure that your units always match. So I have hours and hours here. That's good. What's my time lifting weights, Ashley?
2 hours.
So then what do I do with that? I turn it into a fraction by putting it over 1, and I turn my colon, or my ratio, into division. Bless you. We then apply, what is it, Ashley? Keep, change, flip to multiply by the reciprocal, and it comes out to be 3/8. So the time you spent running was 3 parts of the time at the gym. The time you spent lifting weights was 8 parts of the time you spent at the gym. Jeremiah.
I figured out the actual time of the lifting weights. I get that extra step.
What do you mean? We know how much time he spent lifting weights. So what do you mean?
Mr. Hudson,
So did you compare minutes to minutes at
I
that point?
have a riddle too, Acadia.
Jeremiah, I swear to
Uh,
God.
Hold on. So wait, you can't compare minutes to hours. You can't compare minutes to hours. You have to have matches. So you have to have
You can't steal her riddle thing. That's your trademark.
Before you get out of here, I need you to write down.
No, I have regular deal on gas. Jeremiah,
You gotta go. We don't have time. Talk to me at lunch.
where did you find this?
I'm already late. I'm sorry, Acadia. Talk to me at lunch.